So I've got two. We're gonna start the day off talking about properties of parallel lines. Oh, yeah, go ahead. Talk about properties of parallel lines. There's 5 boxes, but we're gonna do constructions as part of those boxes. So don't worry about that. Okay. So just take a look at this picture. You don't even have to write this part down. Just take a look at this picture here. Are these lines parallel? How do you know and why? But before we do that, has anyone ever done this before? Does anyone know what they're doing? What are they doing? What is this called? A boat. Boat. What? Rowing. They're rowing. Has anybody ever rowed? Has anyone ever rowed? I rowed before. You rowed? Yeah. Do they go forwards or backwards? Backwards. It's weird. They face the opposite way, right? Their feet are strapped in and they're pushing back and forth. Okay. Let's focus on what do you call these things that stick out on the side there? Oars. Oars. They're called oars, right? Weird. Okay. So here's a question to have, right? Are these lines parallel? How do you know and why? What do you think? No. You think no?
I think yes.
You think yes. Raise your hand if you think no. Raise your hand if you think yes. Raise your hand if you think you don't know. You're not sure. Okay. Now, when people are rowing, right? Do you think it's better for them to keep their oars parallel to each other, or does that not matter? What do you think?
Yes.
You think it does matter? Why do you think it matters?
So they've got the same speed.
So they go at the same speed? Okay, what else? What do you think?
And then if they're not parallel, then they'll intersect, and then each oar will hit each other.
If they're not parallel, they'll intersect, and they might hit each other, and then the boat flip over, and they won't go in the right direction. Okay, yeah. So it is advantageous to a rowing team to keep their oars parallel to each other, right? So the question is, right? These seem to be parallel, right? That's what they seem to be. Okay. Well, there's a theorem that says something about a few different lines that are parallel to each other. So if I told you that guy number one, so I have this order here, guy number one was parallel to guy number two, the guy right in front of him, right? Yeah. And then I told you that guy number two and guy number three were parallel. Is that enough to link the first guy and the third guy?
Yeah.
Yeah? Okay, why do you think that is?
Transitivity.
So you say transitivity. What do you mean by that?
Since 1 and 2 congruent,
Yeah?
and 2 and 3 congruent, that means 1 and 3 congruent.
Yeah, and you know what? There's a theorem that says exactly that. And here's what it says. Okay? It says if two lines are parallel to the same line, then they have to be parallel to each other. So this is the theorem. There's only 2 theorems today. This is theorem 3.11. There's a lot of theorems in geometry.
So we're going to have to learn all of them?
We're going to have to use most of them.
Are we going to have to memorize all of them?
No, you have to memorize them, not at all. But you do have to know they exist, and you do have to know when and how to use them. So here's one. So if 2 lines are parallel to the same line, then they're parallel to each other. Can someone apply this kind of to the picture? Kind of just sum it up? Kind of just work on that. Can anyone apply that to the picture in a different way than what I did? Picture of the oars and the boats. Yeah, what do you think?
Yeah, line 1 and 3 are parallel to line 2, then line 1 and 3 are parallel to each other.
If 1 and 3 are both parallel to or 2, then 1 and 3 are parallel to each other. I think, is that what I said? Is that similar to what I said? Yeah? Abby, what do you think? Oh, nothing? Okay. What if 2 and 3 were parallel? And 2 and 1 were parallel? 2 and 3 and 2 and 1.
That's
Basically the same thing again, right? So 1 and 3 are parallel again, okay. So that is theorem 3.11, okay? I want to offer you another picture. Okay? Okay, I want to offer you another picture. I have this books over here, right? These books on a shelf. You guys ever seen books on a shelf before? Yeah, books on a shelf, right? This seems so obvious, but yet it's worded in a strange way, right? It says, okay, so if you're in the plane, I'm just talking about the coordinate plane. If 2 lines are perpendicular to the same plane, then they're parallel to each other. Now that's a really strange way of saying if 2 books are on a shelf, the books supposedly, if they're perpendicular to the plane, like they're sitting upright, they're not leaning over, then the 2 books have to be parallel to each other. Have you ever thought about it in that way before?
Yeah.
You have? That's awesome. I didn't. I never thought about it like that, right? But if 2 books are like sitting on a then assuming the shelf is straight, right? Then the two books are parallel. That's what this is saying, right? So in a plane, if two lines are perpendicular to the same plane, the plane in this case is the shelf, right? And the lines in this case are the books. So it's kind of hard to see, but this is red. You guys see this? Yeah. So I have book number 1, book number 2. So assuming that the books are perpendicular to the shelf, what can you say about the books? How are they related to each other? Parallel. That's it. That's what that's saying, right? Theorem 3.12. So we have two theorems today. 3.11 with the oars, 3 lines parallel to each other. And theorem 3.12, 2 lines perpendicular to a plane have to be parallel to each other. Now, what do you think about that so far?
Wait.
Yeah.
We just went over 3.
What's that?
I thought we just went over 2.
Yeah, just 2. There's only 2 theorems. 3.11 and 3.12.
There we got it. Are they both different boxes?
They're, I'm sorry, what?
Are they different boxes?
Yeah, they sure are. This is box 2. This is the third box.
Well, he didn't count the first one.
Wait, can you do it for a minute?
Sure. I got 1. Oh, why do you say the ladder's bad luck? Well, no one's gonna walk under it. Okay. No one's gonna walk under it. If you want to draw the ladder, go ahead. If you don't, you can just get it later. So here's what you know, okay? If step 1 of the ladder is parallel to the floor, and step 2 is parallel to the floor, why is step 2 parallel to step 1? I mean, it's so obvious, right? It's like painfully obvious, right? Has anyone ever been on a ladder where the steps were not parallel to each other? That wouldn't be a very good ladder, would it? Yeah, what do you think? It's not good. So, okay, well, what can we say? What theorem says that this is true? What theorem says that we're allowed to say this? 3.11. Yeah, that's pretty much what it is, right? 3.11 says that we're allowed to say that, right? No, it's okay. I just wanted to talk about it with you. It's a very visual lesson. Okay, let's do some constructions now.